Proving identities using double angles. So we're going to do some more proofs. Prove that tan x equals 1 minus cos 2x over sine 2x is an identity for all permissible values of x. Earlier in your notebooklet, I had us simplify this down to tan x. So now we're just doing this as a proof. So I'm going to take the right-hand side. So we'll stick to the right side then. I'm going to change this up and then get it to tan x. So choosing cos 2x formulas, I've got 3 choices. Again, I stick to usually sine or cos on its own. I find I have a little bit less simplifying than choosing both. Last time I did this question, we did this one. So I'm going to just choose this one to show that you can still get the answer this way. Both will work fine. So 2 cos squared x is what I'm going to use. So 1 minus, let's put that in there, 2 cos squared x minus 1. So I need brackets around that. Sine 2x, I do not have a choice on a formula. I only have one, so that's kind of nice. You know which formula to use for sure. 2 sine x cos x. Okay, let's bring the negative sign through. Okay. Nothing's changing in the denominator. Now let's combine like terms. So 1 plus 1, so now I have 2 minus 2 cos squared x over 2 sine x cos x. You'll notice we have a lot of 2's in here. What we can do is factor out a 2, so it'll allow us to do some canceling. So I factor out of the 2 out of the numerator. Now those 2 cancel. Okay, so now I'm left with 1 minus cos squared x over sine x cos x. So you might recognize this by now. 1 minus cos squared x comes from the Pythagorean identity of sine squared. I'll just write it over here as scrap paper. Sine squared x plus cos squared x equals 1. If I isolate sine, moving that over, sine squared x equals 1 minus cos squared x. So I can replace 1 minus cos squared x with sine squared x. I'm going to go up here. I run out of room, so we're just going to go up here and go sine squared x over 1 minus cos squared. Oh, whoops, sorry, this is already given here. So sine squared x, meant to write sine x over cos x again. Sorry, I'm going to rewrite that out. Sine squared x over sine x cos x. There we go. Cross off sine x over cos x is equal to tan x, and now we have our left-hand side.